In this lesson, we're going to continue to look at compound interest and solve compound interest problems using the TVM solver. We can use the formula. You can see the compound interest formula here, but in this lesson, I'm not going to be using that formula. We're solving, for the most part, we're going to be solving for P, which means you're going to divide through all the rest of that. But the TVM solver is right at our fingertips and it's easy to use, so just understanding the question and knowing how to use the solver. So present value, that's the amount that must be invested. We often talk about that in terms of our principal. And we want to result in a future value in a certain amount of time given an interest rate. So the first example here says Ginny is 18 years old. She's inherited some money from a relative. She wants to invest some of the money so that she can buy a home in Milk River, Alberta when she turns 30. She estimates that she'll need about $170, not 170, it continues here. So that would be $170,000 to buy a home. All right, so we're not going to use the formula part. We're just going to do the TVM solver. And how do we do that? So 18 years is how old she is, but she's going to do that when she turns 30. So if we go 30 minus 18, that gives us a time of 12 years. Okay? We know that she wants $170,000 at the end, so that's our future value. I'm going to put that in right away, $170,000. And we want to know how much she needs to invest in order to get that. Now, she's not doing this as payment, so I'm going to put a 0 here and a 1 here. So we're not doing a certain payment plan. We're going to put in a one lump sum, so that would be one payment per year. Now, how is this being compounded? It says it's being compounded annually here. So that would be a 1 for CY. The interest rate that she has for this is 6.5. And N then is going to be 12, which is the number of years times 1, which is our compounds per year. So we have everything we need, and we can figure out how much she needs to invest in order to get this amount of money. So let's go ahead and put this in our graphing calculator. So we've got 12 times 1. I would be 6.5. PV is what I'm solving for, but I can't do that till I have my other values in here. Future value of 170,000. And then 1 and 1 for our payments per year and our compounds per year. So now let's figure out how much she needed to invest. Alpha solve. So she needs to save up $79,846.09. Make sure we've got a dollar sign there or rounding to 2 decimal places. Now notice in our graphing calculator that value came up as a negative. Why? Because we're investing it. But when you state your answer, don't state it as a negative. So what you can do if you want here is at this point, at this point here you can write negative $79,846.09, and then at the end you can state that with a dollar sign without a negative sign, $79,846.09 needs to be invested. That way you can separate what's coming out of your calculator with what you're setting and stating as a final answer for the question that you're working on. All right, let's take a look at B part of this question. It says, what is the ratio of the future value to present value for Ginny's investment? So our ratio would just be our future value over our principal, and in this case that would be 170,000 divided by 79,846.09. And you would take that, just divide it, and get 2.13. So that means that the ratio is about 2 to 1. So that means our investment has more than doubled. Part C, how would the ratio change if the interest rate decreased? to 6% but was compounded semi-annually. Okay, so our time hasn't changed and we're still doing our payments as one lump sum. So PMT is 0 and payments per year is 1. But now we're being compounded semi-annually, so CY changes to 2. Their future value isn't changing. But our interest rate has decreased to 6%. So make a prediction. Do you think that you're going to be earning more or less in this way? Do you think the amount that you're going to be investing would have to be more or less than you did when your interest rate was higher but your compounding period was lower? Okay, well, let's have a look. So 12 stays the same. Instead of 6.5, this is 6. And instead of our compounding period to be 1, it's 2. So do you have to invest more or less? You'll have to invest more. Okay? So even though you're compounding more frequently, your rate has changed. So you've got $83,628.74. So it says, how would the ratio change? So the ratio would change because now A over P would be 170,000 divided by 83,628.74, and that would give us 2.03. Well, that hasn't changed that much. 2.13, 2.03. It still has, in this case, it has doubled. Not more than doubled, but it has doubled. If you want to state the amount that you would have to invest as a dollar value, so drastic change? No, but enough if you're saving 78,000 versus close to 84,000. That's significant in terms of the dollar value. Maybe not as the ratio. All right, let's take a look at example 2. It says, Agnes and Bill are musicians. They have researched the costs to set up a small recording studio. They estimate that $40,000 will be paid for the soundproofing, recording equipment, and computer hardware and software that they need. They plan to set up the studio in 3 years and have invested money at 9.6% compounded quarterly to save for it. How much money should they have invested? So we're not going to do the formula, but we will use the TVM solver. So you're going to be flipping back and forth a little bit here. So in our TVM solver, you can just highlight some information here before we flip the page. We've got $40,000. That would be my future value, because that's what will pay for all of what we need. We've got 9.6%. That would be our I. And it's compounded quarterly. So that would be C/Y is going to be 4. Now, it says they plan to do this in 3 years. So 3 years is T. And it looks like we're doing it as a lump sum. So our PMT would be 0 and our PY would be 1. Okay, so let's go and put in all those values. So we've got 3 times 1. I is 9.6. PV we're solving for. PMT is 0. Future value is 40,000. We've got 1 and 4. And we're solving for PV. So go ahead and punch this all in. And then this would be 4. Alpha, enter. And we get $30,092.66. Stating that as a dollar value, when you're stating your answer, making sure you have a $sign and 2 decimal places. So you can see this is, the more you do this, you get used to what goes into which variable, and then it's just plugging it into the calculator and getting your answer. Now B says, how much interest will they earn? Well, the TVM solver in this format doesn't allow us to use solve for the interest. So you can do one of two things. You can use I equals A minus P, and in that case, your future value is 40,000 minus your principal, which we now solved for. And if you do that, you get an interest of $9,907.33. There is a function in the TVM solver, but you need to make sure that your cursor is where PV is. So my cursor is blinking on PV. Now if you go back into Apps, Finance, if you scroll down, you can see here this sum int. That's the sum of the interest. So that's actually an interest calculator. So if you hit enter, that'll be placed where your PV is. It's important that you're in the TVM solver when you're solving this. Now the bracket is indicating the start to the end. So you're starting at year 1 and your term is 3 years. So this is going to be your end value. And then you'll hit enter. And you can see that you're getting close to the same value. There's a little 1 cent difference, but that's another way of calculating your interest. So what did we do there? So this is OR. Use sum of the interest. So this would be from your start to the end. And in our case, sum of the interest from 1 to 3 in terms of time. We got in our calculators, and it was 34 cents, not 33 cents. But as long as you show how you're getting the answer, that would be sufficient. Okay. Example 3, this is our last example for this lesson. It says Laura has invested $15,500 in a registered education savings plan, RESP. She wants her investment to grow to at least $50,000 by the time her newborn enters university in 18 years. What interest rate, compounded annually, will result in a future value of $50,000? Round your answer to 2 decimal places. All right, so again, let's highlight the key information. Okay, so 15,000, whoops, it's not a highlighter. 15,500 in a registered education plan, so that would be our PV. $50,000 is what she wants as her future value. 18 years, that's our T, right? And how are we being compounded? It says compounded annually. So C/Y is 1. They're not saying anything about how, if this is being paid other than one lump sum. So P/Y is going to be 1, and PMT will be 0. All right, let's turn the page and plug all of this in. So we get 18 times 1. I would be what we're solving for, right? We don't know what that is. We're investing, make sure you put negative 15,500, 0, 50,000, 1, and 1, and this is end. So punching this into our calculators, I'm going to let you go ahead and do that. Once you do that, you get an answer of 6.7229. Remember, we're always rounding to 2 decimal places, so that would be 6.72%. Okay. Now B says, suppose that Laura wants her $15,500 to grow to at least $60,000 at the interest rate from Part A. So using your answer from Part A, how long will this take? In this case, we can't use the formula anyways, but we wanted to use the TVM solver. So you're going to take your answer, and you had that answer in as 6.7229 and so on. Leave that in. And that'll give you better accuracy. Okay, we can put everything else in. We're solving for n here. PV, that would be negative 15,000 still. PMT is still 0, PY is still 1. Compounding 1, and our future value, though, is now 60,000. Okay, so make sure you make that change. Punch that into your calculator, and you get 20.802. Now it says, how long will this take? Well, that value is already multiplied by 1 payment per year, but that's okay. So that end value is going to actually represent our years. So 20.8 years. Now compounding is annual though. And we know that if it's annual, we can't get the money until the end of the year. There should be 2 ends here. So we'll round up. So that actually means that it's 21 years before she'll have $60,000. Now realize if PY was something other than 1, we would actually have to divide out to get the number of years, but because it's 1, that doesn't matter in this case. Alright, so that's it for today's lesson. That's how we can use the TVM solver to solve for present value, interest, or even the number of years, the term. Thanks for joining me in today's lesson.